Let's take a look at the large data set. Throughout your 2 years doing this course, you will spend some time looking at a very large data set to do with information on weather from the UK and from around the world. The reason you spend some time looking at a large data set is that it's really important to be able to apply what you learn about statistics and how to analyse and present data to larger sets of data. Out there in the big wide world, there are people who are paid an absolute fortune to work with large data sets. People work for tech companies like Google and Facebook and all the others, and their sole job is to analyse large sets of data. Now, this data set we're going to deal with is nowhere near the size of those data sets, because those data sets, we're talking trillions and trillions of data points. This is not like that, but it's your first foray into seeing something a bit larger than the 5 numbers you've had to deal with at GCSE. So let's have a little bit of an introduction to this large data sets, and over the duration of the course, you'll spend a lot more time becoming familiar with it. So the data set consists of information on data from weather stations across 5 locations in the UK and 3 locations overseas. The locations in the UK are Camborne and Herne down on the south coast, Heathrow near London, Leeming, which is kind of on the north-east coast of the UK, and Leuchars, which is in Scotland. The locations overseas are Jacksonville in the States, Beijing in China, and Perth in Australia. So we have lots of data from the UK, a couple of other data points locations from the Northern Hemisphere, and a single location from the Southern Hemisphere. Now, the large data set records information on 9 variables. Those variables are, first of all, the daily mean temperature in degrees Celsius, the daily total rainfall in millimetres, the daily total sunshine in hours. Now that is measured in the data set to the nearest tenth of an hour. The daily mean wind speed in knots, but also the direction that wind was travelling in. The daily maximum gust, which is also measured in knots. Now, gust is the highest instantaneous wind speed that's recorded. And they also mention, I forgot to write this in, they also mention the direction that the gust was coming from. Also, they record the daily maximum relative humidity. So humidity is measured as a percentage, and it's actually the percentage of air saturation with water vapour. So if the air was completely saturated with water vapour, if you were underwater, for instance, that would be at 100%. And if it was totally dry with no water vapour in the air at all, that would be at 0%. But of course, we're generally talking something, especially in the UK, much higher than that. We're told in the book that relative humidities above 95% are what give us misty and foggy conditions. So that helps you to kind of quantify or conceptualise that number a little more. Now, it's worth pointing out at this stage that on the overseas data stations, the only data that we have are on the mean temperature, the total rainfall, the mean pressure, which I haven't mentioned yet, so I'll come back to that one in a moment, and the mean wind speed. So that's this one here, but there isn't information on any of the others for the overseas stations. So the other points that we then have on the data set are the the mean cloud cover, which is measured in something called octas. Now, I'll be honest, I'd never heard of these until we started teaching this course, and not many people have, but octas, the clue is in the prefix oc, which is also related to this one, or oct, which means 8. And it's actually a measure of eighths of the sky that are covered in cloud. So if the entirety of the sky is covered in cloud, the value of the octas there would be 8, because it would be 8/8 covered. And if half of the sky was covered in cloud, it would be 4, because we're talking 4/8 covered. We then have the daily mean visibility, which is measured in decameters. Now, deca is not a prefix that people tend to come across apart from something like decades or decagon. Deca means 10, not to be confused with deci, as in decimal, because deci or decimal means tenth. So deca is times 10, whereas deci would be divided by 10, getting smaller. So the daily mean visibility is measured in decameters. And that's talking about the greatest horizontal distance at which you can see an object in daylight. And then finally, we've got the daily mean air pressure. Now, pascals here, PA, pascals, is a measure of pressure, which you've probably encountered in your science lessons already. But this is measured in hectopascals. So hecto is another prefix you may not have come across already, and that's the prefix meaning 100. You probably have seen it when you think about areas of land being measured in hectares. And it comes from the ancient Greek hekton, I think, for 100. So hecto means times 100, not to be confused with centi, because you know that as a hundredth of the well, but centi is going smaller. Centi is a hundredth, so don't confuse it with that. So you've got all of these variables recorded in the large data set, and there's all sorts of data on there. Now, if you look on page 12 of your textbook, you'll see a table that's taken from this large data set with quite a bit of information in there already. It's taken from a place called Herne, and that's in the UK, and it's taken from 1987. Now, I didn't mention this before. The data is recorded between May and October in 1987, but also between May and October in 2015 for a comparison. So you have the same months of the year, but from 2 different years quite far apart. So on page 12 of your book, you have this table of data from Herne and quite a few columns here about different types of data. And you'll notice if you look down the very final column, which is the daily maximum gust, there are some values there that say NA. Let me make a note of that. NA, of course, you know, stands for not applicable. Something would be recorded NA if there was some kind of problem with the data on that day. It might be that there was a malfunction in whatever machinery was being used to measure it, or for some reason the result didn't get recorded. So that basically means you have to disregard it, so that we can't use that at all. You'll also see, if you look down particularly the daily total rainfall column, you'll see this, TR. Now TR stands for trace, and trace is a very, very tiny amount, a little bit more than 0, but so close to 0 that you may as well call it that. So when we talk about trace, we're really talking about something very close to 0, but in our calculations, we're going to use 0 for it. So let's have a look at example 5 together. It asks us to look at this table, and it asks us to describe the type of data represented by the daily total rainfall. So the daily total rainfall there, obviously it's quantitative data because it's a number, and because it's millimetres, which is a measure of length, we are talking about a continuous quantitative data. So our answer for part A is going to be continuous quantitative data. And those are the words that we talked about in the last video, you'll remember. Part B asks us, or tells us that a girl called Alison is investigating the daily maximum gust. Says she wants to take a sample of size 5 from the first 20 days in Herne in June 1987. So from the 1st of June up to the 20th of June. She uses the first 2 digits of the date as a sampling frame. Now you'll remember from one of our earlier videos that we spoke about a sampling frame being a list of all the items you're interested in, and an ordered list. So if she uses the first 2 digits as a sampling frame, that's her ordered list there, because the first day is date 1, the second day is date 02, all the way up to the 20th day being date 20. So there's her sampling frame right there. She wants to generate 5 random numbers between 1 and 20. So question B is asking us what type of sample she's doing. Because she's generating random numbers from this list of between 1 and 20, she is doing a simple random sample. But part C asks us to explain why her process might not generate a sample of size 5. So she's taking 5 random numbers between 1 and 20. But why might we not end up with a sample of size 5? Look again at that daily maximum gust column. Some of them say this, NA. So it may well be that we end up with numbers, or we end up with items in the list that are not usable. If that's the case, we would have to ignore them and just try again until we got 5 values. Now, example 6 asks us to do a little bit more work. So it asks us to refer to this table on page 12 again, and we're to calculate, first of all, the daily mean temperature. Don't be confused by the 2 means there. The mean daily mean temperature for the first 5 days of June in 1987. So we look at the table at that first column, daily mean temperature, for the first 5 days, and we can see the values there are 15.1, 12.5, 13.8, 15.5 and 13.1. Now we're asked to find the mean of all of these. So you will remember from GCSE that the mean is where we sum up all the data values and we divide by how many we've got, which in this case is 5. Now the sum of all of these is 70.0, which means our mean is 14.0. Now I'd like at this point to introduce you to a little bit of notation. If we use the letter x for a variable, then we use this notation called x bar to represent the mean. So here we would say that x bar is 14.0, and that's our shorthand for the mean is 14.0. Part B, we're asked to work out the median daily total rainfall. So daily total rainfall is the second of our data columns along, after the date column. And this is from the week beginning the 14th of June up to the 20th of June inclusive. So we're doing all of those dates from 14 to 20. So the values from 14 to 20 are these: 0, 3.7. Oh, I've lost the column. There we go. 5.6, 0.1, 7.4, trace, and 0. And we've got to work out the median. I've written all skew with there, looking at the column, not looking at the table while I was writing. So let's put them in order first. So we've got 0, and then 0, and then this trace. Because you'll remember I said that trace means it's very close to 0, but for our calculations it's so close to 0 that we will call it 0. Then we have got 0.1, and 3.7, 5.6, and 7.4. Cross them off, make sure we've not missed any. So we have got them in ascending order. The median is the middle value, 1, 2, 3, 4. The median is 0.1. I'm going to introduce you to another bit of notation here now. Median and quartiles go together. You'll have learnt at GCSE that the median is in the middle of the data. The lower quartile is a quarter of the way along your data. So here the lower quartile would be this one. The upper quartile is 3/4 of the way along your data, so that would be that one. Now what we do at A level is we call the lower quartile Q1 with a subscript 1, Q1, so that would be 0. Our median is Q2, 2/4 of the way, and our upper quartile is Q3, 3/4 of the way along the data. So this is the one we're interested here. We will think in more detail in later videos about the lower and the upper quartiles. Now, it's worth me pointing out at this stage that you can work out your median and your quartiles using your calculator, and I did say in the last video I'd show you how you do this. These calculators are absolutely superb for giving us more, for calculating statistics and values really quite quickly, and it's much better than the calculators you had at GCSE. The first thing you need to know is that whenever you get your calculator, it's in number 1 mode here, which is your basic calculation mode. But what we want to do at the moment is enter statistics mode, which is number 6. So you can either navigate to it with the arrows, or you can press number 6 there. Now we only have one variable we're dealing with, because in this first question here, we're dealing with the daily mean temperature. That's a single variable. So variable meaning it can take different values. So we want to choose number 1 for single variable calculations. We are going to enter in these 5 values. 15.1, press equals each time, 12.5, 13.8, 15.5, and 13.1. So we've got all 5 values stored. Now, once they're stored, we are going to do some statistical calculations on this table. So you are going to press the option button here, and you're going to choose number 3, which is single variable calculations. And when you do that, you've got loads of things. Look down your list here with the arrows, all sorts of bits of information here, some of which will make sense to you straight away, some of which won't, most of which you will understand by the end of the course. So the top one there, we've got X bar, which is what I showed you before, is our notation for the mean. So that agrees with our calculation. The mean is 14. And you'll be very pleased to know that at A level, you can just type it into your calculator and give that value. And that's absolutely fine and completely acceptable. You have also got, if you scroll down to the next screen, you've got your lower quartile and your median and your upper quartile. Now that's not the same as these, but that's because these were a different set of data, you'll remember. So if we had to give that information for this set of data, that would be the values there. It also tells you, for instance, the minimum value, 12.5, and the maximum value, 15.5. N is the number of data points we've typed in, so that was 5 data points. All these other ones will make more sense soon. If I were to repeat that now for the second set of data where it wanted me to work out the median, I would need to clear this. So I'm going to go I'm going to go to the menu again, I'm going to go back to number 6, single variable, and it's cleared. You can clear it just like you do ordinarily with the AC button or the on button. And we enter in the new data. Now you don't have to do it in order. So 0, 3.7, 5.6, 0.1, 7.4, trace we treat as 0, and 0. So we've got 7 data points there, 1, 2, 3, 4, 5, 6, 7. We go option 3. For our single variable calculations, it gives us the mean is 2.4, and scroll down and we've got the median being 0.1, and we can see that the quartiles agree with what I wrote down before as well. So it's a much quicker way of finding out the information that you need, and that's really useful, and it will come in a lot more use as the course goes on. Now let's quickly take a look at part C. It tells us just before part C that the median daily total rainfall, so that's referring to this daily total rainfall, but for Perth in Australia was 19 millimetres. So someone called Carl says that more southerly countries experience higher rainfall during June. So Carl is saying that Herne, which is in the UK, had a median daily total rainfall of 0.1 millimetres. Forgot to write my units there, my apologies. So he's saying Herne had a median of 0.1, Perth had a median of 19.0, so the further south you go, the more rain you get during June. Now, have a think for a second about why that might not be a valid conclusion. Yes, it's the case that Perth is more south than Herne, but this is a tiny sample. We have one data point taken from a single location in each country. So we haven't got nearly enough evidence to support Carl's statement. And it's really important to remember this key thing, and that is that numbers on their own, without context, are not helpful. And this is something you should remember throughout statistics. And whenever somebody presents any statistics to you on the television, on the news or anything, remember that numbers without context are not helpful. They can be manipulated. You can make people think all sorts of things that aren't really the case by taking statistics out of context. So the context is key here. We don't have a big enough sample. We have a single location in each country. So we do not have enough evidence to say that more southerly countries have more rain than more northerly countries during June. So you can now have enough information to do exercise 1E. Off you go.